Classifying rocks. Rocks are everywhere. Mountains and valley and even the seafloor are all made of rocks. Rocks and mineral resources even make up parts of your home. Today it is common for floors and countertops and even tabletops to be made of some type of rock. A rock is a natural, solid mixture of minerals or grains. Individual mineral crystals, broken bits of minerals, or rock fragments make up these grains. And geologists use the grain's shape, size, and chemical composition to help classify rocks. About 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals. A rock's color provides clues to the rock's mineral composition. For example, granite is generally a light-colored rock that has a high silica content. Basalt, on the other hand, is a dark-colored rock that is low in silica. But as with minerals, color alone does not provide enough information to identify a rock. A rock's texture is also very useful in identifying a rock because most rocks are made of particles of minerals or other rocks called grains. And these grains give a rock its texture. Some rocks are smooth and glassy while others are rough or chalky. To describe a rock's texture, geologists use terms based on size, shape, and patterns of the grains. Geologists are able to classify how a rock is formed using its color, texture, and mineral composition. They classify rocks into three major groups: igneous rock, sedimentary rock, and metamorphic rock. Igneous rocks may form on or beneath Earth's surface. Extrusive rock is igneous rock formed from lava that erupted onto Earth's surface, and basalt is the most common extrusive rock. Igneous rock that formed when magma hardens beneath Earth's surface is called intrusive rock, and the most abundant intrusive rock is granite. The texture of an igneous rock depends on the size and shape of its mineral crystals. Many igneous rocks are hard, dense, and durable, and people throughout history have used them for tools and building materials. Sedimentary rocks are generally formed through a series of processes such as erosion, deposition, compaction, and cementation. In erosion, running water, wind, or ice loosens and carries away fragments of rock. People have used sedimentary rocks throughout history, again for building materials and tools. Sandstone and limestone have been used as building materials for thousands of years because both types of stones are soft enough to be cut easily into blocks or slabs. Heat and pressure deep beneath Earth's surface can change any rock into metamorphic rock. When rock changes into metamorphic rock, its appearance, texture, crystal structure, and mineral content change. Metamorphic rock can form out of igneous, sedimentary, or other metamorphic rock. Marble and slate are two of the most useful metamorphic rocks. Igneous, sedimentary, and metamorphic rocks change continuously through the rock cycle. Forces deep inside Earth and at the surface produce a slow cycle that builds, destroys, and changes the rocks in the crust. Using the image here, one possible pathway through a rock cycle, let's say granite, it starts as an igneous rock formed beneath the surface, and it was forced upward into a mountain. Over time, water and wind wore away at the granite, and these little granite particles became sand carried by streams to the oceans. Millions of years later, in the sandy sediment piled on the ocean floor, the sediment changed to sandstone, which is a sedimentary rock. The sandstone over time again became very deeply buried, and the pressure changed the rock's texture from gritty to smooth. Slowly, this changed sandstone into the metamorphic rock called quartzite. But that does not mean the rock cycle ends. Plates on Earth's crust are constantly moving, and these movements of continental and oceanic crust are constantly colliding. Sometimes these collisions produce folds, which result in mountain ranges. And these collisions can push rocks down deep into the Earth's mantle where heat and pressure change the rocks. And so this rock cycle continues for hundreds and millions of years. Make sure you study this picture, and then let's go ahead and see what we can, time to show what you know.